And whether my screen is visible to you?
Yes, sir.
கேக்குதாப்பா? கேக்குதாப்பா தம்பி?
Yes, sir.
Yes, sir. Yes, sir.
Okay. Okay, guys. Today let us discuss digital engine control system and the different ECUs which is used in the automotive vehicles. So there are n number of ECUs going to used in all automotive vehicle system because each and every ECU is going to play a different role in automotive vehicle system. So today we are going to discuss how different ECU is going to work and how different ECU is used in the IC engines and automotive vehicle system. Okay. So in a digital engine control system, so definitely we are going to use a microprocessor or microcontroller. So that is a central processing unit is going to connected with that. All the sensors and actuator is going to connected together in the CP central processing unit. So that is ICU electronic control unit or module. So we are going to connect everything with that. So which is going to control all over working process in IC engines. In generally, a full authority digital engine control system is consisting of a digital computer is called as an electronic engine controller or electronic control unit. Okay, electronic control unit, and it is related accessories that control all aspects of engine performance. Okay, the goal of any engine control system is going to allow the goal of any engine control system is going to allow the engine to perform at maximum efficiency for a given condition. Originally, engine control system consisted of simple mechanical linkages connected physically to the engine. By moving these levers, the pilot or the flight engineer could control fuel flow or power output and many other engine parameters. Okay, analog electronic control varies in electrical signals to communicate the desired engine settings. The system was an evident improvement over mechanical control, but it had some drawbacks, including common electronic noise interference and reliability issues. Some cases, but nowadays the many of the problems are resolved in electronic control unit. So that is we are going for digital control unit. So when we look into this digital engine control system, so here we are going to give a FADC. So this is a full authority digital engine control system. This F FADEC, it is shortly called as FADEC. So this FADEC is a system consisting of a digital computer, as I said earlier. It is also called as an electronic engine controller or electronic control unit. So all accessories that is control all aspects in IC engines. So better main advantages of using this digital control system is so we can achieve better fuel efficiency and automatic engine protection against out of tolerance operations, carefree engine handling and with the guaranteed thrust settings and ability to use single engine type for wide thrust requirements by just reprogramming the FADEC. So it provides semi-automatic engine starting and better system integration with engine and aircraft system. So this will reduce the number of parameters to be monitored, and due to the high number of parameters monitored, so the FADEC makes possible fault tolerant system. And next, so the here as I said there are many classes. We have also seen the many of the sensor signals are connected to the controller. via our input or output subsystems. Similarly, the input output subsystems is provides the output signals to drive the fuel injectors, as shown in the diagram below. A solid state control system includes hardware for sampling and analog to digital conversion sets. All sensor measurements are in format suitable for reading by the microprocessor. So this system is totally a closed loop control system. So here we are having uh, the input and output devices systems. So this is a engine. From engine we have a ignition. Okay, for example, if you are going to use a four number of cylinders, so you are going to provide a four ignition coils or ignition control system for each and every cylinder. And then next is a fuel control system. So the fuel is going to control. So and next is the mass airflow sensor. The airflow is also going to monitor. In between we will have a throttle. So when we are going to press or rotate a throttle, it is depends upon the vehicle which you are using, whether it is a two-wheeler or four-wheeler or whatever it is. So when you are going to press, the throttle valve is going to open. So based upon open angle of the throttle uh, valve, so the airflow rate is going to increases. So when airflow rate is going to increase is based on the airflow rate, the amount of fuel entering into this mixing range is also increasing, and everything is going to mix it together, and then it will pass through the engine during the suction stroke. So here you can see the mixture. So the engine is going to pass through this suction. The air fuel mixture is going to pass through to this engine cylinder during the suction stroke. And next, this is the throttle position sensor we have. So this is also monitored because we have the digital thing in engine control system. So here we have a throttle position system and the mass airflow sensor also here we are using. So this is also monitored. Here we have an input and output control that is connected with the EC electronic control unit and module. Okay, the fuel control. So this fuel control and the throttle position and mass airflow sensor, everything is going to be connected with the ECU as well as exhaust gas recirculation. Okay, when depends upon the varying speed and load condition of your automotive vehicles, so everything is going to be monitored. Then, based on the speed and load, the amount of air fuel entering into the cylinder is going to vary. And this is the power. Okay, and the from engine exhaust, so the amount of hydrogen, how much oxygen is going to present is going to monitored here, as well as this will pass through the emission is going to pass through these the catalytic converter areas. So finally, it is we will have the silencer. So from the silencer, the exhaust emission is going to be sent it. So next is EGR, exhaust gas as gas recirculation valve. So this EGR, mm, whenever the exhaust gas is needed, how much amount of oxygen is going to present in that, so that oxygen going to be used from the exhaust gas. So the oxygen is going to be separated, and it is going to be passed uh, instead of the air, or with the air the amount of oxygen is also going to be supplied. Huge amount of oxygen is going to be supplied, and the amount of oxygen value entering into the mixing with the fuel ratio is also increases here. Okay, so similarly each and everything is going to be monitored in each electronic control unit or engine control unit or engine control module. Okay, and in each and every operation is going to be monitored, and the every functioning will be controlled by this ECU. Next is the control system selects an operating mode based on the instantaneous operating conditions as determined from the sensor measurements. As I said earlier, the sensor is always monitor each and everything. So depends upon the input received from the sensor to the ECU. Then ECU will take care of the torque, the operating mode, and how much amount of air fuel needs to send to the cylinder, and whether you need to improve the ignition system and spark timing, and each and everything is going to be taken care by the ECU. And then ECU gives some order or command to the actuators. And within any given operating mode, the desired air fuel ratio is going to be selected. The controller then determines the quantity of fuel to be injected into each cylinder during each engine cycle. The quantity of fuel depends on the particular engine operating condition as well as the controller mode of operation. So this is engine crank mode. So while the engine is going to be cranked, that means when it is started, the fuel control system is must provide an intake air fuel ratio of anywhere from 2:1 to 12:1, depending upon the engine temperature. So here the correct amount of air fuel ratio is selected from a read-only memory or lookup table as a function of a coolant temperature. Because the program, we have already stored the program for varying load and speed condition of our automotive vehicle and temperature. Each and everything is going to be analyzed and everything is going to be prepared as a program, and it is uploaded in the microprocessor. Then so based on that, when engine is going to be in operating condition, so the amount of air fuel mixture ratio and everything is going to be sent based on that. The low temperatures affect the ability of the fuel metering system to atomize or mix the incoming air and fuel. So next is the engine warm-up mode. So while the engine is warming up, an enriched air fuel ratio is still needed to keep it running smoothly, but the required air fuel ratio changes as the temperature increases. So here the control system stays in open loop mode, but the air fuel ratio comments continues to be altered due to the temperature changes. So finally, the emphasis in this control mode is on rapid and a smooth engine warm-up. The fuel economy and emission control are still a secondary concern. So here we have some of the automotive control system module. So body control module, passenger door module, airbag control module, rain sensor module, sunroof module, electronic vehicle information instrument cluster,
In automotive electronics, electronic control unit, ECU, is any embedded system that controls one or more of the electrical system or subsystems in the vehicle. The electronic control unit, ECU, is a general term for any of a number of computer modules that receive input from sensors in the vehicle and control different electrical functions. They are the computer brains of the vehicle. As autos become more complex and outfitted with more sensors and functions, there can be dozens of different electronic control units at work in a single vehicle. The ECU often consists of an 8-bit microprocessor, random access memory, RAM, read-only memory, ROM, and an input-output interface. ECUs may be upgraded by the manufacturer or by a third party. They are usually protected to prevent unwanted tampering. Electronic control modules types for Jeep Grand Cherokee WJ as example. Body control module, BCM. Body control module, BCM, is attached to the junction block, under the driver's side of the instrument panel. The BCM utilizes integrated circuitry and information carried on the Programmable Communications Interface, PCI, data bus network along with many hardwired inputs to monitor many sensor and switch inputs throughout the vehicle. The BCM supports many body electrical features such as interior lighting, exterior lighting, intermittent wipers, remote radio, accessory delay, and heated seats. Door module, PDM. Passenger door module, PDM, is located behind the right door trim panel, integrated within the door switch assembly. The door modules control various electronic features such as power door locks, power windows, power mirrors, courtesy lighting, and the lift gate lock motor. Airbag control module, ACM. Airbag control module, ACM, is located underneath center console housing, behind the shifter assembly. The microprocessor in the airbag control module contains the supplemental restraint system logic circuits, and controls all of the supplemental restraint system components. Electronic Vehicle Information Center, EVIC. Electronic Vehicle Information Center, EVIC, module is located within overhead console. The Electronic Vehicle Information Center is an interactive display system. It gives the driver some information such as compass, temperature, and trip. Sunroof module, SM. Sunroof module is located in the overhead console as part of the sunroof assembly. Sunroof module controls operation of the sunroof open, close and vent functions. RainSense module, RSM. RainSense module is located inside of the windshield, between the rear view mirror mounting button and the windshield header, concealed behind a molded plastic trim cover that snaps over the module housing. The microprocessor-based rain sensor module senses moisture in the wipe pattern on the outside of the windshield glass, and sends wipe commands to the body control module, BCM. Instrument cluster, IC. Instrument cluster is located left dashboard. Instrument cluster provides gauge and indicator control. Instrument cluster utilizes the PCI bus to obtain most, but not all, of the information needed to control the gauges and indicators. Driver door module, DDM. Driver door module, DDM, is located behind the left door trim panel, integrated within the door switch assembly. The door modules control various electronic features such as power door locks, power windows, power mirrors, courtesy lighting, and the lift gate lock motor. Heated seat module, HSM. Heated seat module location is under the driver's seat, mounted on a bracket that is located between the power seat track and the seat cushion frame. Heated seat module, HSM, performs heated seat functions. Memory heated seat module, MHSM. Memory heated seat module location is under the driver's seat, mounted on a bracket that is located between the power seat track and the seat cushion frame. Memory heated seat module, MHSM, performs memory seat functions and heated seat functions. Adjustable pedals module, APM. Adjustable pedals module location is under dash above brake pedal. Adjustable pedals module, APM, controls operation of the adjustable pedals. Sentry key immobilizer module, SKIM. Sentry key immobilizer module location is under the steering column opening cover, attached to the bottom side of the steering column housing. The Sentry key immobilizer module contains a radio frequency, RF, transceiver and a microprocessor. The SKIM transmits RF signals to, and receives RF signals from the Sentry key transponder through a tuned antenna ring integral to the SKIM housing. Transmission Control Module, TCM. Transmission Control Module, TCM, is located on the right side of the engine compartment near the firewall, mounted to the inner fender, or on the left side of instrument panel. The Transmission Control Module controls all electronic operations of the transmission. The TCM receives information regarding vehicle operation from both direct and indirect inputs, and selects the operational mode of the transmission. Controller Anti-Lock Brakes, CAB. Controller Anti-Lock Brakes, CAB, is attached to the Hydraulic Control Unit, HCU, under the hood, in front of the master cylinder. Controller Anti-Lock Brakes, CAB, controls the ABS. Also controls Electronic Brake Distribution, EBD. Powertrain Control Module, PCM. Powertrain Control Module, PCM, is located on the cowl panel, right rear side of the engine compartment. The PCM is a pre-programmed, triple microprocessor digital computer. It regulates ignition timing, air-fuel ratio, emission control devices, charging system, certain transmission features, speed control, air conditioning compressor clutch engagement and idle speed.
Okay, dear students, I think you have better understanding of the different types of ECUs and modules and electronic control modules. Probably electronic control modules used in automotive vehicle system. So a number of control system and control modules and electronic devices are used in automotive vehicle system for different purposes and different applications. So I think you have seen all the items which is used in the automotive vehicle system. Okay. Okay, dear students, rest of the things we will see in the next class. Okay, thank you for your presence. In case any doubt, you can ask me.